Hi dears, this is Raji. In this video, we are going to discuss an easy method to memorize the lanthanoids. What are lanthanoids? These are elements which are coming after lanthanum. You can see these elements at the bottom portion of the periodic table from cerium to lutetium. Memorizing the elements in the order, their atomic number and electronic configuration is a challenge for us. But there is an easy method. So let's see what's that, and we will discuss the questions also related to that. Now see this picture. This is chemistry professor Nidan Pradham. He is trying to educate somebody. Read and find out. Chemistry professor Nidan Pradham simply educates good techie boys directly. How to earn tomorrow, yearly and lifelong. Using this sentence, how can you recollect these elements in the order? See this one. Chemistry. From that we can recollect cerium, that is Ce. Professor, that is PR. Praseodymium. Nidan, ND. Neodymium. ND is the symbol. Pradham, that is promethium, PM. Simply, SM, that is samarium. Educates, EU, that is europium. Good, that is gadolinium, GD. Techie boys, that is TB, terbium. DY, directly, that is dysprosium, DY. How? Holmium, HO is the symbol. To earn is erbium, ER is a symbol. Tomorrow, that is thulium, TM. Yearly, that is ytterbium. And lifelong, that is lutetium. You should remember. Easy, no? Okay, yes. So you can recollect a meaningful sentence in your memory for a long time. So using this sentence, you will be able to recollect all these elements in the order. So one work is over. The next work is to write the atomic number of all these elements correctly. We had already discussed a short trick to memorize 3D, 4D and 5D series elements also. In that, we were discussing the atomic number of scandium. What was that? 21. If you are adding 18 to that, you will be getting the atomic number of yttrium. What is that? That is 39. If you are adding plus 18 to that, you will be getting the atomic number of lanthanum. Lanthanum will be having atomic number 57. So these elements are coming just after lanthanum. So what will be the atomic number of cerium? That will be 58. Okay. If you could memorize all these elements in the order, you can write the atomic number of that elements also. Got it? So we learned how to memorize lanthanoids in the order. Their atomic number also we got. Now we need to learn the electronic configuration also. So only for cerium I have written the complete electronic configuration. In order to answer questions, we need only this outer electronic configuration. The electrons which are present in the innermost shell won't be taking part in the chemical reaction. So we don't want to memorize. So the same electronic configuration we can write it in one more way. What is that? This is the electronic configuration of xenon. Okay. What is the atomic number of xenon? That is 54. Now, what will be the outer electronic configuration? It will be 6s2, 4f1 and 5d1 also. So, in order to answer the questions, you will have to memorize how many electrons are present in 6s, 4f and 5d. Now, let's write the electronic configuration of all these elements. In all these elements, 6s will be there, 5d and 4f also will be there. Memorizing the number of electrons present in all this subshell, it is too difficult. So, there is an easy trick. So, see this one. Using this one, you can write the electronic configuration of all these elements. All lanthanoids will be having 2 electrons in the s subshell. Now, cerium, gadolinium and lutetium will be having 1 electron in 5D. All other elements will be having 0 electron in 5D. That means cerium is the first element in the lanthanoid series. Gadolinium is the 7th element and lutetium is the 14th element, the last element of lanthanoid series. Only these elements will be having 1 electron in the d subshell, right? All others will be having 0 electron in d. Now come back, let's write the electronic configuration of all these elements. So what is a trick to remember? All these elements will be having 2 electrons in the s subshell. So we don't want to memorize that. Okay, there is no change in the number of electrons in the s subshell. All of them will be having 2 electrons. Now, how many electrons will be present in 5D? In cerium, then gadolinium and lutetium will be having 1 electron in the d subshell. See this one, cerium will be having 1 electron in the d subshell. Then gadolinium will be having 1 electron and lutetium also will be having 1 electron in the d subshell. All other elements will be having no electron in the d subshell. They will be having 5d0 configuration. Easy. You need to remember only these 2 points. So in s subshell, 2 electrons will be present in all these elements and only in cerium, gadolinium and lutetium. First, 7th and 14th element will be having 1 electron in the d subshell. All others will be having 0 electrons. If so, easily you can find out the number of electrons present in 4f subshell because you know the atomic number. What is the atomic number of cerium? That is 58. 54 plus 2, 56 plus 1, 57. So 1 electron will be present in the f subshell. Then praseodymium, atomic number is 59. Okay. Already 54 electrons are present in the inner orbital. 54 plus 2, 56. Okay. So 3 electrons will be present in the f orbital. Easy, no? Yes. So each and every element, the number of electrons in the f subshell will be varying. It is difficult to memorize, but using this trick, easily you can write the electronic configuration. Now, in the case of gadolinium, find out how many electrons are present in the f subshell. See, what is the atomic number of gadolinium? That is 64. 54 electrons are present in the inner shell. 54 plus 2, 56. 5d1 and 7 electrons will be present in the 4f subshell. Okay, Now find out for holmium. What is the atomic number of holmium? That is 67. Then 54 is already present. 54 plus 2, 56. How many electrons will be present in the f subshell of holmium? That will be 11 electrons. Okay, so easily you can write the electronic configuration of all these elements. I have written the number of electrons which are present in the f subshell of other elements also. You can check it. Okay, easy, no? Now we are going to do certain questions also related to that. Then idea will become much more clear. See this question. If you could memorize all the elements of lanthanoid series in order and their atomic number and electronic configuration, you can answer a number of questions. Okay, see this one. The electronic configuration of europium, gadolinium and terbium they have given, and you will have to choose the correct electronic configuration of these elements. Try that. So what is the electronic configuration of europium? All the lanthanoid series will be belonging to 6th period. So 6s will be definitely there and 5d will be present and 4f also will be present. Okay. Now we will have to find out the number of electrons which are present in s, d and f subshell. All these elements will be having 2 electrons in the s subshell. Okay, there is no change in that. Again, you should remember the first element, 7th and the 14th element, cerium, gadolinium and lutetium will be having 1 electron in the d subshell. Others will be having 0 electron. Okay, only in gadolinium it will be having 1 electron. Europium also, terbium also will be having 0 electron. How many electrons will be present in the f subshell? It will be 7 electron. Okay, what about gadolinium? 64. So 7 electrons will be present in that. Okay. Now see this one, terbium. Terbium atomic number is 65. Okay, that is 56. Then how many electron will be present? That is 9 electrons will be present in the F subshell. Okay. Now check which option is correct. Yeah, that is the fourth option. That is the answer. Easy. Now see this question. Which of the following lanthanoid ions are diamagnetic? They are asking. So atomic number is also given and all these elements are lanthanides. Okay. So cerium, 54 electrons will be present in the inner orbital. As they belong to 6th period, 6s will be there, 5d will be there, 4f also will be present. Cerium is an exception, we said, right? Yeah, it will be having 1 electron in the D subshell and all these elements will be having 2 electrons in the S subshell also. Then what will be the number of electrons which are present in the 4F subshell? Yeah, that will be 1 only, right? No. So they are telling cerium 2 plus. From where electrons will be missing? Yeah, from the outermost orbital, right? No. Yeah, electrons are missing from the S subshell also. Yeah, see, 2 electrons will be present in the inner orbital. Unpaired electrons will make that ion, yeah, paramagnetic. Okay, so this is not the answer. Now second one, samarium. Yeah, 54 electrons will be present in the inner shells. And what about the outer shell? 6s will be there, 5d will be there and 4f also will be present. 2 electrons will be present in the S subshell and as it is samarium, okay, yeah, see D0 configuration it will be having. How many electrons will be present in F subshell? 54 plus 2, that is 56, okay. So atomic number is 62. So the number of electrons that are present in F subshell will be 6 electrons, right? See, but they are asking samarium 2 plus. So from the outermost orbital, yeah, the 2 electrons will be going. Still, yeah, the F orbital will be having unpaired electrons. Correct? No? Yeah. So due to that, yeah, it will be paramagnetic. So that is also not the answer. What about europium? Yeah, so that electronic configuration will be 54. Yeah, then 4f, 5d and 6s. 2 electrons will be present in S subshell, okay, and 0 electrons will be present in the D subshell. How many electrons will be present in the F subshell of europium? Atomic number is 63. 7 electrons will be present. All the F orbital will be singly occupied, correct? No? So due to the presence of this unpaired electrons, yeah, this also will be paramagnetic, okay. So what about ytterbium? Yeah, 54 we will write. Yeah, 4f will be there, 5d will be there and 6s also will be present. So in 6 subshell 2 electrons will be present. In D 0 electrons. And what about F? 70 minus 56. 14 electrons will be present and all of them will be paired. So due to that ytterbium 2 plus will be diamagnetic. That is the answer. Got it? Yes. Yeah. See this question, lanthanoids are 14 elements in the 7th period. Lanthanoids belong to 6th period. So this option is wrong. 14 elements in the 6th period. Atomic number 58 to 71 that are filling 4f sublevel. Yeah, it is correct only. Then what about this one? 14 elements in the 7th period. This is wrong. Yeah, lanthanoids belong to period 6. Then 14 elements in the 6th period but atomic number given is different. So this one is also wrong. What is the answer? Answer is the second one. Easy. See this question. Gadolinium belongs to 4F series. Its atomic number is 64. Which of the following is the correct electronic configuration of gadolinium? So which is a trick to remember? Yeah, we will write xenon 54. Lanthanoids belong to, yeah, the 6th period. So 6s will be there, 5d will be there, 4f also will be there. In all that lanthanoids, 2 electron will be present in the S subshell. What about D? As it is gadolinium, it will be having 1 electron. Then how many electron will be remaining in F? Yeah, so 54 plus 2, 56 plus 1, 57. Yeah, as its atomic number is 64, 7 electrons will be present in 4f subshell. Okay, so which is the answer? Yeah, 4f7, 5d1, 6s2. The answer is first one. So easy, right? Yeah, give reason why cerium 3 readily oxidized to cerium 4. This is a board question. In the question, they have not given even the atomic number also. Then how to answer this question? Yeah. So we will have to remember cerium is an element present in the lanthanoid series. So it will be coming after lanthanum. Okay. Yeah. If lanthanum is 57, atomic number of cerium will be 58. Right. Now write the electronic configuration. 54 electrons will be present in the inner shell. Then 6s will be there, 5d will be present, and 4f subshell also will be present. As it is cerium, the first element will be having 1 electron in the d subshell. S electron will be always 2 in lanthanoids. Okay, then what will be the number of electrons present in the F subshell? It will be 1 only. Correct? Yeah. Now the question is that cerium 3 plus readily oxidized to cerium 4. Yeah. Now write the electronic configuration of cerium 3 plus. 3 electrons are missing. Right. So it will be having 4f1 configuration. Okay. Yeah. It has got only 1 electron present in the F subshell. Correct? No. If it is missing this 1 electron, yeah, that it can attain the inert gas configuration, which is at xenon 54. So due to that, cerium 4 plus will be having 4f0 configuration. In order to attain that, cerium 3 plus will be readily giving away 1 electron and will be getting converted into cerium 4 plus. Got it, no? Yeah, so this is also very easy for you. We have discussed a very small topic, but you have answered these many questions. Please like and subscribe for more videos. Keep on working hard. Thanks for watching.